and I will hand it over to Martin, our guest from Honeycomb. So the talk is not all technical, so I'm not going to talk technical stuff in the beginning. So I'm just going to give a bit of general stuff. So, okay, all good? Yes. So first, I wanted to put some numbers in perspective. Last year, we had an internal conference in our company, and our CEO went on the stage and he said, "I've met the 8 most influential people in NHS, and we're going to be doing X, Y, Z, right?" And then there was another talk after that, and he said, our software is used by 1.539 million users in NHS. So those were the numbers that were mentioned, and so I thought, let's put these numbers in perspective, right? So how much is the 8 most influential people on the top versus 1.5 million people that are actually using our software? So and then I took this picture on the left, which is 8 people in 2 meters distance, so they span across the room. And then if you put 1.5 million people span 2 meters, you'll get from Skopje more than London. It's like Edinburgh, somewhere right there, right? It's their house, yeah. So this is how many users are using the software versus how many are in contact with high level executives, right? So on day-to-day basis, our customer support and people that we have direct communication are between 500 and 1,000, and the actual users are 1.5 million, right? So it's very hard to get the feedback from 1.5 million users of how your application is actually running, because it's very hard to get those people to show up. So the traditional ways are like NPS scores, and you get surveys, and you get that feedback. But it's actually, there is the concept of silent users. So the silent users it reminds me of a story. It was my first work experience in a company. So I got employed on a Monday, and we went to Croatia on Wednesday. So we spent there like a few days and getting to know the software. It was a software for medical workers as well. And what happened is, a colleague of ours just dislocated his shoulder, and we had to go to the hospital, and we went there with our team lead there that was from Croatia, and they had to enter his details in the system that were onboarded the previous 2 days. And the system got stuck, and our team leader asked that person, said, "Okay, but what do you do? Because I work the system, I need to know." He says, "Oh, this happens on Tuesdays always, and give it a few hours and I'll do it later on." So that doing it later on means that she might do mistakes when entering the data, because it's a bit later. People forget things a bit later. And those scenarios are never reported. So I'm not going to report this because I found a workaround. I'll just do it in the afternoon. That's when the system actually works, right? So observability gives us a mechanism to get and find these users that are experiencing slowness, they're experiencing errors, and they're not going to actually report them into the traditional way. So usually this is like the journey of a feature, and it's usually you write a piece of code, and it's usually like you plan it, you develop it, no matter how fast you go through this cycle, and then you push it and it lives in production, right? So when it lives in production, the world of production is a very unpredictable place, because it has a lot of different users, different workloads, different clients, different sizes of databases. Almost everything is different than what's on your local machine. What you do with observability is you say, I'm going to send my code to production, and I want my code to say some things back to me from over there, from the world of production, right? So it generates information. This generating information, we call it telemetry data, because it's generated from a remote location, and we are capturing that data to software like Honeycomb. I can't mention anything else, but there are different tools, but Honeycomb is the best. And then we are asking Honeycomb questions to reason about our system that's running in production. And currently, we can ask these questions with AI. So those are some new functionalities. Maybe Martin will and can mention them later on. And of course, we can be alerted and send alerts back to us. So this is what is all about, right? So we have this rich data in our systems, in systems like Honeycomb, and we allow our stakeholders to ask questions to those systems. So now we can all reason about that data. It's not just engineers, it's also other departments, it's customer support, it's legal and compliance, because they all have different interests and different types of questions that they are interested in the system. Customer support wants to know one thing, engineers want to know something else, sales teams want to know something else as well. And having tools like Honeycomb and generating telemetry data gives this shared context to those teams, so it's actually breaking silos in the process as well. And the title of my talk was like the modern engineering, and what makes the engineering modern. Actually, you can say at any point in time modern engineering. So if you said this sentence 5 years ago, it would be modern engineering because of the time we live in. But it's like usually when time goes, the technology grows, and huge systems usually tend to get more and more complicated over time. So for example, if you had a system 20 years ago, you might have 2 clients, now you have 200. Your data was 2 years old, now it's 20 years old if you don't clean it up. I hope you do. Then you have identity providers, external, you host it differently, the technology grows, so all that complexity needs rich telemetry data so you can actually reason about your system. So in a nutshell, that's what I wanted to say to you today. I'm handing over to Martin. So yeah, we are all happy to hear what you are going to say to us.
Hi everyone. I'll be next and announce our next speaker while he is preparing his laptop. What I researched, there is that he is from Oldham, that's Greater Manchester area, the area where the weather is changing so frequently that observability is not just a software skill, but it's a survival skill as well. So the thing is that Martin is international speaker on many conferences, Microsoft MVP, observability Evangelist, and he is not starting his explanation of the issues in production with the words "I think," but it's based on telemetry and evidence instead of on the opinion. So today he will start and just explain how to engineering a .NET telemetry with OpenTelemetry Weaver, and make sure that we understand the whole topic and everything that he has to tell us. The
Awesome.
stage is yours.
Thank you. So, because Honeycomb was bigged up in the last talk, I should obviously say that I'm only here because of RLDatix, who brought me over to help out with our Innovation Day. It's been an amazing week. Thank you very much for bringing me over. So, if you are looking, I know it's a no recruitment, but if they are looking for people, they're really good people. So this is a talk that I've done it in a few places recently, and it's around a tool called OpenTelemetry Weaver. I'm going to talk a little bit about what that means, but really this is about the why. When we start doing telemetry in .NET, this is kind of the pinnacle of .NET, right? You just you add some of these counters and some activity sources and throw some logs in and throw some activities in, and hopefully we get observability, right? We get this idea of being able to know what's going on in our production system. Now we like to call that accidental observability, because you've kind of thrown them in with no real idea behind them, and hopefully when you go into production and you look at your logs database, hopefully, fingers crossed, the information that you need is there. It's information in a format that you can understand, It has the right context in order to be able to do it. That's why we call it accidental observability, because you're not really putting any engineering around it. What you're really doing is dropping a load of things in the file. One fun story, and I think I told this earlier to somebody, but we had a customer that was complaining about the volume of their logs, and obviously as a platform that takes telemetry data, we charge people for sending us data. We charge people by the number of items that they send us. That's a very specific detail that's important. So I went through and I was looking at their logging data and looking at why things were wrong. We identified that 10% of their logging data just said here. Somebody had thrown logger.information here into their code. That had gone to production. That was on a really, really tight loop, and that was 10% of their data was just here. I mean, I'm pretty sure there was another one like also here as well, but the idea is that we're not really putting any thought or engineering behind how we're putting this telemetry out. There was no real standards. Everything is magic strings everywhere. I have a little bit of a pet peeve about people who use magic strings now. Please just use a constant. Put a constant in your code and use the constant everywhere. Stop using magic strings. This is bad. I mean, it's bad for various reasons, but anyway. So my name is Martin. I am a developer advocate for a company called Honeycomb. We're a backend where you can send your OpenTelemetry data. I worked out recently, I wrote my first line of code 30 years ago. That is depressing. But I've been talking about observability, and prior to observability, I've been talking about the monitoring industry for the best part of 15 years now. So I think it's important that I instill on you what I mean when I talk about observability, because words are important, words have meaning. So when we say observability, what do we actually mean? It's that, right? We log our information, get student, and the student ID is this, and no, we didn't find a student, and oh, the student name was this. That's observability, right? It isn't. That's telemetry. When we talk about modern observability, we're talking about the idea that we can understand what our production system is doing. Observability isn't about the data. You may have heard people talk about the 3 pillars of observability, which is logs, traces, and metrics. And then somebody went, well, no, it's not just logs, traces, and metrics, because there's also exceptions and profiles and events. So actually it's not, melt was the term, it's actually temple. And then somebody went, no, there's actually 11 pillars of observability. Like, there isn't. Pillars don't exist. They're called signals. These are telemetry signals. Now, if you imagine, like when I started out developing, this was like the pinnacle of application architectures. Somebody'd have their browser. I mean, Edge didn't exist back then. That was definitely not the Firefox logo when I started. But you'd have your load balancer maybe, and then some applications that are load balanced on there, and then you'd have the database, and probably that's all on the PC that's right next to your desk at home. And the idea was, at that point, we actually had a really easy time, because grabbing a log file from the server that exists next to your desk and then grepping that log file, because you've probably only got 100 users, was really, really easy. So logs was enough back then, just writing out log files and saying, oh, I was here, or I was also here, but saying like, well, I got something from the database, this is how many rows I got, was really, really easy. So it felt like at that point you were actually doing some engineering. If I make a database call, I log the database call. I log my SQL statements. I turn on logging in Entity Framework so I can see all of my SQL queries. And hopefully we've got a correlation ID somewhere that allows us to be able to grab logs for an individual request. But then this happened. Does anybody remember this diagram? So this is a diagram from a company called Monzo in the UK. They put out a blog post in, I think it's about 2018, 2019. They put out a blog post and said, we have 1,400 microservices. What's worse is they said that like it was a good thing. And the rest of the development industry went, no, that's you did a bad thing. Don't tell people that you have 1,400 microservices. That's not, they now have 3,200 microservices, by the way. I spoke to them recently. But they built this architecture of distributed systems with tons and tons of microservices. And all of a sudden, the idea that you could just grab the logs from the disk on the machine that was next to your desk in the office goes out the window. The idea that you can just log a .log line on your code base and be able to understand that the request that starts here went all like that, you're not going to be able to do it. That's when tracing came up, more specifically distributed tracing. But still, we're not talking about observability. We're still talking about telemetry data. So what do we mean when we talk about modern observability? It isn't about your individual bits of data. It has absolutely zero to do with your logs, metrics, traces, events, profiles, nothing to do with that. It's all about the outcomes. Everything else is an implementation detail. If somebody tells you that to have observability, you need logs, metrics, and traces, they are wrong. You can get observability through pure logs. You can get observability through pure metrics. You can get observability through pure traces. You need one. I mean, you can't do it with none. That would be hard, I suppose. I mean, if you don't have a system, having no logs would mean you've got observability. I suppose that would work. But you need one signal. That's all you need. The more signals you have, the more understanding you can get. And the outcome that we're looking for is, do you understand what your production system is doing at any given point? Can you work out that an error that happened is because one user who signed up when they were in Norway, who is now in France, and is using the Norwegian language pack on iOS 14.1, and it turns out that we pushed a language pack last week, but we forgot to push it to iOS 14.1. Like, can you do that? Can you know that right now with your system? Most people can't, and if you have a dashboard that has exactly that data on it, first of all, can you tell me what the lottery numbers are next week? Because that is some level of clairvoyance that you knew that that specific combination of things was required. But also, you're probably wasting data. You're probably wasting a lot of things by trying to work out these things. Now, the other thing about modern observability is it is not about just doing things when things go wrong. It's not about, well, observability is for production, right? It's when things go wrong in production. That's what observability is for. Observability really is about the whole software development lifecycle. It's about this idea of, if I'm developing software right now, shouldn't I know how that software is being used by customers right now? If I make a change to this line of code, would I act differently if that's a line of code that is hit on every single order that goes through my system? Would I treat that differently than something that happens once a week because Dave runs it, and Dave just runs one process at the end of the week and he just clicks a button? Like, those two different circumstances, would you treat your code differently? And do you know which ones of those two you are touching? If you're right at the top of your stack, you probably know. If you're on the /product endpoint or the /checkout endpoint, you know that that's to do with orders. But if you're 4 levels deep in your stack, do you actually know all of the places where that's used? And not just, I'm not talking about find all references here. I'm talking about in a distributed system, do you know where that is used? Do you know which endpoints it comes from? That criticality is important when you're writing code, because you will treat it differently. You'll write different tests. You'll understand it differently. But the other thing is, it's not just an engineering issue. It's not just a DevOps issue. It's not just an SREs issue. The idea that the DevOps movement that got everything wrong, that, you know, we ran a conference recently, and one of my speakers had the best analogy of DevOps and how things have changed. Because we used to have Dev and Ops, and what you do is you throw over source code over to the Ops team, and the Ops team would build it and then deploy it. And now what we do is we throw over a Docker container, and the DevOps team just go and host it for us. It's the same thing. It's still a brick wall in between two teams. It's just we throw Docker containers instead of source code now. Building telemetry and building it properly, building it with engineering, is an engineering issue. It is something that product engineers should do. It is something that application engineers should be thinking about. Because saying that my service is deployed now, that's the SRE's job to make sure that things are running. It's not my job. I typey the code codes, and you do the rest. That isn't what modern observability is about. This is where we get back to that accidental observability. If I throw a load of logs out, and then hopefully the SRE and DevOps team will take all of those logs and they'll stick them in a database, and hopefully, they'll be able to work out what's wrong. And if they can't, well, that's their problem. I'm just going to go to the pub. That isn't what modern observability is about. It's not what modern engineering is about. Now, one of the big problems that we had, if we go back, say, 5 or 6 years, is your DevOps team, your SRE team, what service are they using to understand production? Is it Honeycomb? Is it Datadog? Is it Dynatrace? How do I, if they decide to change between Datadog and Dynatrace or Honeycomb, and I've implemented my code with Datadog, now all of a sudden all my 1,200 microservices now need to change the way that they instrument in order to use the new tool that they've just decided on Tuesday that they were going to move, and now all of a sudden there's another downstream work. Well, that's where OpenTelemetry comes in. Show of hands, who knows what OpenTelemetry is? Wow, this is getting better. I mean, all of the RL people, obviously you know. But it's pretty impressive because I asked this question in various different places, and until last year, pretty much nobody knew about it. So the fact that there's such a wealth of you who know about it is quite good. For those that don't, the OpenTelemetry as a project is from somewhere called the CNCF, the Cloud Native Compute Foundation. If you've not heard of them, they're famous for, I think it's shipping. I don't know, it's something to do with containers. Kubernetes? I don't know. Apparently it's a big thing. But that should give you an idea, because OpenTelemetry is now the #1 project from the CNCF. It is a graduated project. It is supported in the same way as Kubernetes is. It has more active contributors than Kubernetes right now. That's how important of a project it is. Now, the reason why it's important is because it is completely vendor agnostic. It doesn't tie itself to Honeycomb. It doesn't tie itself to Datadog or Dynatrace or any of the other vendors out there. The idea is that we're going to decouple the engineers who write code and instrument their code from where that data ends up for you to be able to go and look at it, and for your engineering team to go and look at it, and your SRE team to go and look at it. And that allows us to pull this into actual engineering now, because we don't need to consider the bespoke library from a particular vendor. What it allows you to do is instrument once. There's no longer this fear that, well, they're going to change their tool. It's like, you change your tool, fine, just change the environment variables and send it somewhere else. And 99% of the time, you don't even do that because your applications are sending through an OpenTelemetry collector, and it's the collector that changes anyway. So we can actually spend some time, we can curate and make this better. Now, the other thing that makes this really important is something called the semantic conventions. Now, I am a very, very pedantic person. I love a good naming debate. Now, let's see a show of hands. How many people think they've lost at least a week sat in a room with your colleagues deciding on what to name something? I think you're all lying. I think everybody in the room has lost more than a week with people in a room going, no, we should use plurals for our database tables. It should be orders. And it's like, no, it should be order. It should be order. They're interesting. I love them. I absolutely love them. However, they're not exactly productive. They don't add any value to the business. Order or orders is fine as long as everything's the same. As long as you've got a convention, it is fine. Now, what OpenTelemetry did is we got a load of really pedantic people and put them in the room for the last 3 years. And they have a meeting once a week where they decide what these common elements should be called. And then about 2 years ago, Elasticsearch came up and said, we've got this entire schema of what everything should be called. Would you like it? And we're like, but we've just spent 2 years naming everything. And that's called the Elastic Common Schema. They were merged about 2 years ago, and it was an absolute nightmare. The entire of the OpenTelemetry community was up in arms for a very long time. However, Elasticsearch had a very, very big following already in the logging space, so we merged them up. So things like, what is the URL for my site? Under what attribute should that live, and what should that be called? There are things that are common across very, very many people's environments. If you're using HTTP calls, you've probably got http.url somewhere. But then somebody else says, no, it's not really a URL, it's a URI, right? So it's http.uri. And somebody else goes, yeah, but it's not really HTTP. Should we just like start it with URL? And should we have like url.path and url.queryString and change them up? And that led to a real big problem at the vendor side. Because now the vendor side has to support 72 million different conventions for, which one did they put it in? Did they put the URL like this? Well, they've put url.path, but they've actually included the query string on there, and that's not going to work for us. So they came up with these conventions for all of those common things so that you don't have to anymore. If you're using HTTP, if you're using messaging, if you're using databases, if you're using document databases, if you're using event streaming systems like Kafka or NATS or something like that, all of these are all defined now. What isn't defined, though, is your business data. There is nothing in the OTel data that says, oh, you're an e-commerce platform, so you want order.id, right? Yes, but we also want order.loyalty.id. Oh yeah, and we also want loyalty.tier.id, because we are tiered loyalty here. And loyalty.program is also something that we do. OpenTelemetry does not cover that. And what that means is that you end up with a lot of different attributes across your entire business. One of my favorites is the deployment environment. So you have an environment, you have a variable on your telemetry that says, which environment did this telemetry come from? Was it the test environment? Was it the pre-production environment? Was it the p-prod environment? Or was it the pre-prod environment or the pre-production environment? Are these all different environments or are they all the same? Because I have been in an organization where they had 5 different names for their pre-production environment. It was exactly the same environment, but 5 different teams decided to call it 5 different things. It's like, well, we refer to it as staging. Like, everybody else calls it pre-production. Should we just everybody call it pre-production? That is important. Having consistency in your telemetry is really, really important. And this comes down to building database data strategies. Anybody remember this? Anybody old enough to remember these diagrams? So this is an entity relationship diagram, an ERD, that in the early days of SQL and SQL Server, you'd build all these out. The amount of time that you'd spend trying to make sure that these lines didn't cross and move these around and go, it's like a puzzle from the Crystal Maze or something. Like, can I just move it so I don't cross any lines? And if I move that, can I move that thing over there and then make it come down? I think I can, if I just move this down. We'd spend so much time. Forget naming debates, that was way more fun. But the idea was that we'd spend so much time on building out schemas. The amount of time we'd spend on, is it person? And I'm sorry if you are a plurals for database names person and this is making your eyes twitch, but I'm sorry, you are wrong. They should be singular. But we'd spend so much time, not just on the database table names, but we'd spend time on, should we separate out course into a different table and then have a foreign key back? We'd work out, well, middle initial or middle name? Do we have middle initial and middle name? Is middle initial actually a view that we put on top of here? We'd spend so much time on the data strategy. Why? My theory is that we did that because as engineers, we used it. We'd spend so much time because we'd use this every day. We'd be writing SQL queries every day about this structure. So we cared about it. The logging strategy, I don't really care about that. That's for the guys over the wall. I don't know who they are. I don't know what they look like. I just throw my stuff over there and they do stuff. But I don't use it. They'll just tell me when something's wrong. That's my theory. I don't know whether that is true, but that is my theory. So that's just a little story to give you a little bit of framing around where we come to. Now, when we look at telemetry, we talked about pillars before. We talked about the different telemetry signal types: logs, traces, metrics, profiles, events, exceptions, all of those different types. There are only really 3 different types of telemetry that you need to care about. The first one is unstructured data. Unstructured data is log lines that are just pure text, normally come out of system appliances, syslog if you're on Linux, or coming out of the event log. Event log is semi-structured out of Windows. But we have unstructured data, which is just strings on a disk. That's all they are. In my opinion, throw them all in the bin. They're not useful. The other type is structured data. Structure can come in various different forms. It could come in protobuf serialized. The most common form would be JSON. We have JSON structured data. Normally has a format to go with it. And that covers 3 different types. It covers structured logs, spans, and also events. Events is a new telemetry type in OpenTelemetry, which is a structured log with a schema. It's a brand new type that is, it came out, I think, 4 months ago now. But those are your main 2 types that most people understand. Unstructured data, just logs on a disk, log lines on a disk. Structured data is where we've got some kind of JSON format, so they've got names, you've got key value pair with attributes, maybe you've got a nested structure in there, but you've got some structure to it with names. And then the third type is pre-aggregated data. You may hear this referred to as metrics. What we do there is we take a load of context, so maybe 20 or 30 requests. We condense them down to a number, which would be 20 or 30, and add some attributes on it, and we aggregate that at source, so inside of your application. Those are the only 3 telemetry types that exist. Those fall under structured data, those fall under pre-aggregated data, those go in the bin. And then we have to think about data strategy. We have to think about where things are useful. This is where we get into that engineering aspect, because knowing when to use a particular type of data, a particular signal type, is really important. Why is that useful? So when we talk about metrics, metrics are the idea that I have a question that I want to ask. I would like to know the average request duration by endpoint. So we generate a metric that has the duration property, has it as an average, and then we segregate that by the HTTP route or route, depending where you are in the world. But we segregate it by those. I know that that's a question I'm going to need to ask, therefore I generate that data up front. We call these known unknowns. These are the questions that we know that we need to answer, but we don't know the answer yet. They're really useful if you are building a dashboard, for instance. I mean, God forbid, don't build dashboards. We're in the age of AI now, you don't need them. But if you are building a dashboard, if you're building an automated report that you need to put in front of your exec team, that you need to run once a week, you know exactly the graphs that need to appear on that chart, then generate that data up front. And the reason is because metrics are the cheapest data type that exists in telemetry, because they're incredibly small on disk. They're incredibly big when you start to get to high cardinality data. The running joke is everybody tries to put the user ID on their metrics once, and then they watch as Prometheus rocks in a corner just saying, please, will you stop sending that? It hurts. And that's not a slight on Prometheus. It's because time series-based metrics, these pre-aggregated data, are not built for high cardinality. There's a few workarounds that you can do, but inherently, they are not built for high cardinality data. They are built for known questions that you want to ask. Now, the other telemetry type would be logs or log events. Log events are something that happened at a point in time in your system. Exceptions are a really good example of this. At this particular time while this method was running, an exception occurred. It has properties that go alongside it. It might be the request started as another one. If you've got a long-running connection like a WebSocket, a SignalR, or something like that, socket opened is an event that happens. It'll have some characteristics, what we call cardinality. What we call dimensionality. It'll have different attributes that you put on there. It might be the source that it came on, the user agent that it came from. But they're point-in-time data. That's what they're used for. You use it when you want to know that at this point in time something happened. And then we've got traces or spans. Spans are the currency of observability. Metrics are the currency of dashboards. Logs or log events to a certain extent, but mainly traces and spans are the currency of observability. And the reason is because we call them wide events. You create a span, and then you append data to that span as it goes through your system. So you get a web request that comes in, and then you go, oh, well, I grabbed something from the database. Well, I'll add the amount of rows from the database that came on, so I know that this request generated this number of rows from the database. It was for this user. That user was part of this group. Instead of logging out 20 lines that says, oh, I got 5 lines from the database. Oh, this request is for this user. Oh, putting them on one event, way cheaper and way easier to aggregate, way easier to be able to work with. But then we get on to adding things like business context. All the stuff I was talking about there is pretty much out of the box with OpenTelemetry now. You've got the OpenTelemetry auto-instrumentation agents, which if you're using .NET or Python or Java or JavaScript, it's a couple of lines of code in your startup, and you'll get all of that easy information out. However, it doesn't know what you are. It doesn't know that you're an econ platform or a telecom platform. It doesn't know any of these things. And that's where your business comes in. Your business context, something that's unique to you. But not just unique to you, but also unique to your individual systems inside your organization. Examples, stuff like the loyalty program ID, maybe the stock ticker symbol if you're a trading platform. If you're a banking platform, so source and destination banks for a transfer. Those are not PII data. You're not throwing in account numbers and names and addresses. But they will let you know that maybe all of the transactions that are slow between banks are going to one particular bank. That's interesting to know. It could be postage tracking information, if you're tracking where things are delivered. It could be that, well, all of the deliveries that go to this particular, we're sending the orders to this particular courier. And it turns out they're rejecting 10% of the orders. Well, that's a great stat, and we've got a metric that says 10% of the orders are failing. Great. What if you could know that 10% of the orders are failing because it's going to a particular region of the country that that particular vendor doesn't support anymore, or they're having some problems in their downstream system? There's no auto-instrumentation that's going to give you that. So how do we solve it? Well, we solve it with something called Weaver. Now we could, obviously, all of those things I was talking about, you could go and use magic strings in your application and just go, yeah, I'll just put postage.region as my attribute in there. Great, okay. So you put postage.region and then the other team go and put postage_region in their system, so now I can't pull them together. We need standards. So Weaver is an application telemetry schema. Now I say application telemetry schema because that's what we called it when we started building it. But it's not really, it's business telemetry schemas because it can live at multiple levels. It can live at your organizational level, it can live at your department level, it can also live at your individual application level. What we essentially do is build registries of attributes, of metrics. We give them meaning. We give them purpose for being there. We tell us, why is the postage tracking information there? What does postage.region actually mean? Is it, in the UK, would that be the first part of the postcode? Is that what we mean by postage.region, or are we actually talking about a city? Is the city the things that ends up in there? Because then one team is putting their city in and another person is putting their postcode in. Unless you know what should be there, we have problems. It does a few other things as well, though. It does code generation. So it uses Ginger templates to generate code that you can use in your application. No more magic strings, but also no creating constants on your own. It will be able to do it. You can also generate documentation. You can generate some little documentation sites, and I'll show you how to do some of that in a minute. But one of the most important things is something called live validation. One of the big problems we have if you're in a dashboarding world or if you're in an alerting world, if somebody decides, I'm going to remove that log line, and you've got an alert that's based on that log line appearing, and then all of a sudden that log line doesn't appear anymore. Have you heard of the term load-bearing logs? Where somebody just goes, oh, I'm just going to remove that thing. Oh, the house fell down. How do you know? How do you know that that particular attribute isn't there anymore? Well, Weaver allows you to be able to do that. I see there's a few people looking around and going, that would have been really useful last week. Yeah. So what it allows us to do is generate documentation like this in everybody's favorite language, YAML. Because we thought about it and we thought, what does the world need more of? YAML, obviously. You can do it in JSON. You can also do it in TOML if you are really that way inclined. But most people will do it in JSON because they're normal people. But it allows us to be able to write, these are attributes for spans. It allows us to be able to say, this is the actual name of that value. So app.shipping.amount exists. It should always contain a double. Fun story, when I built this out originally, I built this out on the OpenTelemetry demo, which is a demo system that we built with 15 different microservices in different languages that allows you to spin up and see OpenTelemetry in action. When I went and built this, I asked Claude to go and build this for me, just go through and build a schema for me. It was a really good way of doing this. And then we ran live validation and found out that our telemetry was actually wrong and inconsistent over the entire platform because one of them was passing a string into the amount field. And we didn't realize until we ran Weaver against it and went, oh, well, yeah, okay, it was useful. But you're able to say like what it is. Your stability levels, you can put some notes against it and give it some examples. This brief and this note are really, really important. Way more important now than when we started building Weaver. Because we were starting to build Weaver before AI was a thing. Or not before it was a thing, but before it was as big as it is. Now we can use these things to tell an AI system why that attribute exists. We can tell it that a bigger number in amount is bad, or a bigger number is good. We can tell it if you see this on a graph, up and to the right is better than down and to the right. This should remain constant. We can give it those bits of information so that when we're using an AI, an agent or any kind of LLM to analyze our telemetry data, it's not just going to go, it went up and to the right. It can say, oh, it's going up and to the right, you should do something. I don't know whether AI is going to change its voice like I did, but it'll at least be able to tell you that there's some context there that's important. That's specifically how we do attributes for spans. Metrics gets a little bit more interesting because we give it these metrics, these attribute types. But if you look down here at these metrics, what we're doing is we're saying this is a counter. This is the unit of measurement. So this particular one is measured in milliseconds, or it's measured in the recommendation units. You can tell it with these annotations where it should exist. So this should always exist only on the recommendation service. And we'll come on to why that's interesting in a minute. But you can also give it things like requirement levels. So this should always exist on that particular service. So that when you're doing a live check, If that doesn't exist, it's going to throw an exception and tell you that you've done something wrong. And then you can group them together, give them names, and give them all this kind of stuff, which is really good for generating documentation. So you can generate documentation like this, little command line like this. I actually run this in a Docker container because I don't like anything touching my disk, so everything can be run in Docker container. And you can just build documentation polls like this, so that your entire team can investigate what telemetry should exist in your application, can investigate why it should exist. You can actually upload these schemas into your backend systems like Honeycomb, and I don't know, I think Datadog is doing it now, maybe, but most of them are working on this. So that when you're looking at your data inside of your platform, you don't have to go back to the YAML files and try and work out what they are. All of these descriptions will be readily available to you. But you can also use it to generate code. In case you can't read that, that is generating some C# code in the background. And then we get on to live validation. There's a couple of different ways to do this. I've seen various different people do this in different ways. The main way that we're pushing people right now from an OpenTelemetry perspective is running this as part of your integration tests inside of your CI/CD pipeline. Hooking up your telemetry from your application, possibly going through a collector, and having the collector push out to your telemetry backend. If you're not pushing out telemetry to your backend during your CI tests, try it. It's incredibly insightful. Throw it out to your telemetry backend, but also send it over to Weaver, which is a little live check executable that runs. And then any exception reporting you can throw onto your observability backend. Okay, now before I get onto the next section, because I've talked a lot, and I'm assuming that people want to see some code, because code's interesting. So how many people in the room have heard of Aspire? Not .NET Aspire. I don't want to invoke the Fowler. It is Aspire now. Just Aspire, no .NET. David, no .NET, right? I joked with him recently that I think he's got an alert on Twitter, so that anybody who says .NET Aspire on Twitter, he immediately gets a notification so he can jump on and go, there's no .NET! But Aspire, it seems like a lot of people haven't heard of it. Now, Aspire is a tool that Microsoft developed. They said it's to replace Docker Compose files. I don't think it does, and I don't think it ever will. But the best thing to come out of Aspire was the Aspire dashboard. The Aspire dashboard is a local observability platform. It can take logs, metrics, and traces and allow you to view them in a local context. Very specifically, it has a 20,000 span buffer. You can't send more than it. You send more than that, and it'll lose the rest of them. It is specifically built for you to look at things locally. So I built this little application, which I'll share the repo, and you can go and have a look and play with it yourself. But it's all built with Aspire. And duplicate. That coming through? Yes. Okay, question for people at the back. Can you see that? You want it bigger? How's that? Yeah? Cool. So this is an Aspire application where we're running up live check. This is the Weaver live check. Don't use that version. That is very old. But like a professional, I decided not to try and upgrade everything just before my presentation. I didn't sacrifice enough things before I came for the demo gods. So we're running the live check. We're running an OpenTelemetry collector. And then, ignore that. That's a bug in Aspire. And then we're running a to-do application, which is a two projects. And then we've got a load test running with K6. And then we've got a docs site. Now, the interesting part to show you here is the docs, because this docs repo here if we look at this Docker file, what this Docker file is doing is using something called mkdocs, which is an open source project that takes markdown files and generates websites from them. So in here we've got a, no, we don't want that. Don't join a meeting, no. That would have been interesting. So what it's going to do is it's going to use mkdocs to go and build this. And what that does is we have various ones of these templates. These are those Ginger templates that I was talking about that build markdown files from the conventions repo. Sorry, no, not from the conventions repo, from our telemetry schema. So we've got different services in here that reference different attributes. We've got all of those things, all those YAML files that I was talking about. And what that allows me to do is, if I do that, again, there's going to be an exception here that tells you that some of my packages have security vulnerabilities. You want to try and hack my laptop? Absolutely go at it. There's nothing interesting on there. But this was me not wanting to update things before my talk. So it's going to run Aspire. What Aspire is going to do is it's going to run up all of those different applications that I just talked about and provide me with a dashboard to go and view them. And we want that one with the token. And this is Aspire with all of our things running. So we've got this docs site. And if I click on the docs site, you can see we've got our telemetry in there. We've got our to-do service will be in there. We've got all of the telemetry files that exist. And you can go through and view all of the different things that are in there. I tried to brand it. I hope you appreciate the branding on there. But yes, I tried to brand it a little bit. But the idea is you can then go and see all of that stuff. It's using those markdown files to go and build a telemetry portal for you. Now, if you imagine that what we can use that for is inside of an organization, if you've got 20, 30, 40, 50 different teams, not only can we generate a shared NuGet package, most organizations now don't use one language. They've got a .NET team, but they've also got a front-end team that like writing in that JavaScript thing. So maybe they need an NPM package that has constants in for their telemetry. Maybe you've got a team that's doing some AI stuff with Python. Maybe they need one as well. But we need the same conventions in each of them. So we can use the conventions repo here is where we've actually generated all of that data. So we can go and use it. I apologize about this. I move a lot. I blame whoever built this stage. I'm sorry. But we can generate all of that data that we can use, and now we've got constants that we can use, which makes things a little bit easier. But we can build then a documentation portal, host that on GitHub, the GitHub pages, as part of your build pipeline. Whenever somebody adds something to their build pipeline, you can now go and go and look at the website to see where it is. But you can also build a centralized repo that grabs all of these telemetry schemas and builds one big repo, one big website where people can go and look at all of the telemetry from all of the different systems. But what you'll notice here as well, if I go into the logs and look down for just the Weaver stuff, you can see that what we've done, because we ran that load test against the application, it's actually telling me things that are missing. So the deployment environment is missing from there. We've got an issue with the host.id is only in development, so we shouldn't be using it. All these things that you can then tune from a centralized perspective and say everybody needs to use these particular schemas. And now all of a sudden you don't get the problem where somebody deploys some code and removes some telemetry that you really were relying on. Now, one of the really cool things about putting telemetry schemas in the repo is if I look at the manifest document, in the manifest we've got dependencies So I can actually have a Weaver config inside of my repo for my service that I'm working on that references the OpenTelemetry semantic conventions. It references the department conventions for my particular product, but also represents the organizational conventions. If you're in an organization where you have multiple different products that don't work together, then fine, each one of those has their own product conventions. But at an organizational level, we say that these should look like this. And at a service level, I have things that other services don't use, so I'm going to define those in my semantic conventions. That means you can have approval flows. If somebody says, I would like to add something to our organizational conventions, okay, well, now we do a PR, and now we spend 3 months in a room arguing about whether it's a plural or not. And we get back to the good things. But if you're doing it in a repo, one of the cool things about GitHub is you can actually do different workflows based on which files have changed. So if somebody goes in and removes that particular attribute that you were using on your alerts, well, all of a sudden there's now an approval flow because they have to remove it from Weaver as well, otherwise Weaver will fail their build. And now there's an approval flow that says, well, you're not going out because you've changed the schema. So I now need to approve that, or some other person needs to approve it. So it gives you this idea of now we're actually getting into real engineering of telemetry. Now we should care about it. Now we should care about the names, care about where they exist inside of our repos. And then the final thing that we can do is something called the term is called Rego policies. I hate the name, but it's something from what's called the Open Policy Agent, another CNCF project. These allow us to go a little bit deeper. So this one here, when Weaver live check is running to work out whether something exists or not, it's also going to say, on here, there are, on this deployment.environment name, there's also an annotation that has a list of potential names. So no, you can't say that you call it staging and everybody else calls it pre-prod anymore. Because the schema says, no, these are the 4 valid values that you can use. That doesn't mean that they can't go and PR something into your organizational repo and say, we're creating a new type of environment. This new environment is called Dave, and we want to put Dave as the environment name. And then everybody goes, why are you calling it Dave? It's like, well, it's really, really unreliable, so we're going to call it Dave after Dave in the office. So you can actually go through that process now and have approval processes, have policies yourself around how people add conventions. We're no longer throwing bytes on a disk and hoping that we start to get some consistency and telemetry, because a good telemetry strategy doesn't rely on hopes and dreams. It relies on engineering. And my belief is that, and the reason why people weren't putting engineering around telemetry before was, A, somebody could move my library and I'm no longer using DD trace, I'm using DT trace, or I'm using the Honeycomb event manager or something like that. That was part of it, but also there was no incentive. Now there is. Because now you can take these things and you can upload them into your observability platforms. So, where are we? That one there. Now you might look at me and say, that sounds like a lot of work. But it's not, it's one prompt. And it doesn't even use a lot of tokens, to be perfectly honest. Because what this allows us to do now, when we've got things like Claude, it'll do a grep on your environment and just go, right, search for everything that says activity, search for everything that says span, search for everything that says tracer. And it'll grab them all out and build a Weaver config, because it knows what Weaver configs are now. Weaver's been out for long enough that it is now part of the weights of all of these models. So unless you're using something from about a year ago, then you're probably fine, and it will include those schemas. So it knows what Weaver is, and it'll go and build these things out for you. You can actually build these as reusable skills to push into the teams and say, go and define your own schema. Just run this. 1 PR. Done. Now you've got a baseline. Now we can add Weaver live check. Oh, it says there's some things missing. All right, well, let's go and add them then. Don't fail the build until you've got a clean Weaver thing, and then you've got a starting point that you can change from. It isn't hard anymore to go through and add 400 attributes. But then you've got a central registry that you can go through and say, we've got 5 different teams that are using something to do with product ID. Some people say product underscore ID, some people say product ID. We need to come up with a convention. Great, pull that out, stick it at an organizational level. And then push it back down to them, and then everybody needs to change and conform over time. With agents, this isn't a problem. Now, the other thing that this really helps with, that is the end of all of that stuff. I just wanted to add one thing on the end of this. AIs need context, whether that's an AI that you are using to look at your observability data from your vendor, or whether that's you using Claude, Codex, Cursor locally to use an MCP from your vendor. It needs context. It needs to know why things exist. You don't get that from log lines in your code base. You don't get that from the agent going off to your MCP and the MCP saying, oh, there's a log line that says here somewhere, go and find it. It's like, well, there's 17 of them. 17 places this thing exists, I need to go and remove them. You don't get that without using something like Weaver to provide yourselves with a glossary, an index of what these exist. It helps everything. It helps you if you're going to use Claude to debug your production system. It helps if your vendor also has an agent inside of their backend, because you can upload these files to them and now they know why they exist. They know where to go and search for them in the code base if they've got something like a GitHub integration with your backend. All of this just helps the AIs, makes token usage so much smaller because it doesn't have to search the code base to find out why something exists. It references your Weaver files. Throw that in your agents MD, throw that in your Claude.md, so that you can then say, go and look at the Weaver files if you need the definition for this metric when you've gone off to the MCP. You'll save a ton of tokens. We're estimating right now from people that we've talked to that have been using these, somewhere between about 20 and 30% fewer tokens if you are using a MCP to go and debug your systems. And you're doing this with a proper strategy. And 20 to 30% fewer tokens is a lot of money. So go and try it out. The repo is on my Practical Open. There's a GitHub org called Practical OTel. Go on there. All of my OTel stuff is on there, and this is on there. You can pull it down, you can run it yourself, and you can go and play around with it. But I'm going to be around for a little bit, so if you've got more questions and stuff like that, come and ask me. If you want a demo of Honeycomb, I can do that as well. But thank you very much for having me. If anybody wants a public question, I can do a public question as well.
Yeah, sure. I was just, just going through what you just said, that obviously this is not meant for small teams, like micro teams or stuff like that.
Why not?
It could be. No. It could be. I'm just saying, mostly where you triggered me on this thing is that you said like, oh, let's share an NPM package or whatever. In your opinion, this is just simply opinion and experience. The deal is, how do you actually enforce this in a large, many teams enterprise, or 20, 40 teams, as you said it, when there's without a mono repo, when there's a lot of repos, how the hell does that thing scale out?
How do you enforce people?
Because the Rego stuff really triggered me.
Okay.
The Rego stuff triggered me. That how the hell do you?
How do you currently enforce Dependabot to make sure everybody's dependencies are scanned and updated every time they go through?
CI/CD.
There you go. Same place. If you've currently got a mechanism for enforcing that people have Dependabot checks, that have sonar checks, that have all of those things, this is just another one of those.
So you simply just reference the main repo and type of deal, and then you enforce it against that.
Yeah. So if somebody, so that registry that you saw on there, that manifest file, so this manifest file on here exists inside of this service repo. So imagine that this is one of your 400 or 1,500 microservices. This is one repo with one service in it. It has a manifest. It has its own conventions in there, but then references back up to the organizational level conventions. Now, yes, so that one there is saying this is my .NET Macedonia engineering telemetry scheduler. But it references the OpenTelemetry semantic conventions. It could also reference, I don't know, the conventions for .NET in general if those existed. If this doesn't exist, and you enforce the conventions, you just say, well, I'm just going to use this one directly. There's no reason why you have to have this in there. If they don't have any unique conventions, they don't need them. But you can enforce then to say, right, I've built my own GitHub action that does Weaver. Well, it knows how my organizational structure works in terms of repos, and if it doesn't find that one, it's just going to use this one over here, and it's just going to apply to every single workflow in my organization in the same way as I do with Sonar, same way as I do with dependent bots, same way as I do with GitHub Advanced Security. If you're doing those things already, you've already got a mechanism to be able to enforce at an organizational scale that certain checks are run inside those pipelines. But this is not something that I would say, if you've got 50, 60, 100 teams in your organization that you can do on day one. Absolutely not. The way that I've seen adoption work in all of the observability world is by showing people the benefit of doing it. Now, fun story, one of our customers, they came on to us about 3 years ago now, and they were using Jaeger, and they had one of the biggest Elasticsearch and Cassandra clusters I have ever seen in my life, because that's how you back up Jaeger. And they were throwing all of their data in there. And they started on a path of sending their data through the collector, sending it to Jaeger, so it still existed, and then sending it to us. And they had something like 20 or 30 teams that they were dealing with. But there was one team where the reliability of that team's product didn't follow the trend of everybody else. So everybody else was getting more and more reliable because the schemas and their telemetry was all a little bit more reliable. So they went to that team and they were asking, like, how can we help? You know, it seems like you're struggling with the reliability when other people aren't. So, like, what are your unique challenges? And they turned around and said, yeah, well, everybody else is cheating. They're using Honeycomb. Like, they turned around and was like, you know, you could do that too. Like, if everybody else is doing a thing, you can do that. The best way to get people to adopt things is to show them. I mean, we were talking about this the other day, that if you enforce something, if you have to go in and say, you must do this, that means that that team doesn't want to do it. Why do they not want to do it? Make them want to do it. If what you're providing is something that's easier, if it's something that gives them a benefit, they will be grabbing your hand and pulling you into the room and saying, please show me how I do that thing. I want to do it now. If you have to force somebody to do it, it's obviously not providing enough value for them to be able to want it. That's probably not a good place to be. So make it easy for them to do it. Provide some GitHub actions that are there, provide some NuGet packages, provide a skill in Claude that they can just go, yep, just add Weaver, and great, it's going to go and do my add Weaver for me. I don't need to do anything. Have an agent go through and add a PR to all of their repos that does the basics for them. All you need to do is hit accept, and it'll be there. If there's no benefit to them that they can see, then they're not going to adopt it, and they're going to fight against it. This will make their lives easier. Go and show them. Choose a repo. Find a champion team. Go and sit with that champion team. Implement it with them. Get them to be the ones that are going out to the rest of the teams like, you know what we did last week? Like, we had no downtime, ever. Like, and they're like, how did you do that? Well, you know, we implement this Weaver thing, and now all of our telemetry is consistent, and we've got loads more telemetry in our system, and we can really analyze these things, and we can fix all these bugs a little bit easier now. And then that will just happen. And every single team, that word will get out, and everybody's like, how can I talk to the observability team and ask them for some help to do this? Like, yeah, get in line. There's 50 of them in front of you. You're a bit late to the party. That's how you do it. If it's got no benefit, don't do it.
That does not apply only to your problem. Let me just tell you that.
Oh, yeah, yeah. I mean, this is the way that we talk about DevOps. This is the way we talk about centralized teams in general. The new style of scaling organizations is consulting teams. So it's like a consulting SRE or a consulting QA. The way that those teams work is by showing that they add benefit to the teams that they go into. And then everybody comes to them and says, can you help me with this? Yes, I have tools, I have products that you can use, absolutely. Win hearts and minds by showing them that their job is going to get easier if they ask for help. Does that answer your question?
Key term, champion. Find the champions and send them off.
It's champion teams. So one of the things we found is individual champions aren't good enough. One person in one team isn't good enough. You need that whole team. If you've got dissenters on that team, it's really bad. You want an entire team of people to be on board with what you're doing. Yeah. Yeah. You might start with one person, but if that whole team doesn't go, then you're not going to get it. Any more questions? Okay. I do not disagree.
So my question was to you, what's your opinion on logging, let's say, 10 variables instead of, let's say, all of them, 70, 50, 100?
So this is a really controversial thing. Now, full disclosure, the way that Honeycomb price changes my opinion on this. So when we built our system, we built it so we kind of push people into the pit of success, which is wide events. We don't charge by the size of the data you send us. We charge by the number of events you send us. So in my opinion, send all 70. As long as they're not PII data, send all 70 of them. If it's really sensitive data, maybe hash it before you send it in, but 100% send all of that data. If you're working on a platform that charges you by the gigabyte, that might change your opinion on it. But in my opinion, they should be as wide as possible. Go wide, don't go deep. Now that doesn't mean, and this is a debate I'm having with somebody on LinkedIn at the moment, that doesn't mean never create another event.
What do you mean by going deep? You said you go wide but don't go deep. What do you mean by that?
So deep would be, you've got 70 attributes that you want to log. Deep would be, let's take each of those 7 attributes and put it, 70 attributes and do 10 log lines instead. So that's going deep. Wide would be taking all 70 of those and throwing them on one. Now what you might need to do though is, and I talked about log events, the point in time things, there's also using those when you've got like a certain area of your code you need to go, right, I hit this thing at that point, great, okay, 1 extra wide event in there. You might also have like the crown jewels is your algorithm that changes its performance based on the inputs that comes in. So you want to measure the duration of that particular algorithm. That's another wide event. As a general rule, every application will have one span that says span kind server, and it'll have numerous spans that say client, which is like a database or a third-party API. That's sort of bare minimum. And you might have some internal spans, but prefer just like leaving those 2 layers and just add to the span. Make it wider and wider and wider. The reason why that's important is because I was a database engineer in my career, and I can tell you that joins are bad. If you can get out of doing a join, get out of doing a join. If you go wide on your data, you don't need to do joins. You can do where clauses, you can do filters, all of that kind of stuff. It just makes everything faster and everything easier if everything is on one line. You don't need to do joins anymore. That's the reason why wide events are so much better. because you're essentially giving it more context. Here's the HTTP request. Here's the URL. Great. Here's how many items were in the basket. Here's the loyalty program they were part of. Here's the source IP address. Here's the user agent they used. Wider and wider it gets. Now I can go, show me the distribution of response times by the user agent where the basket was above 50 items. You have to do that with logs. That's going to be almost impossible to run at scale. So the wider the event, the easier it is. But that's why we say, give all of those events, all of those attributes, names that mean something. So when I say basket items, what does that actually mean? Oh, it's the count of the items in the basket. Great, I now know what that means. I can apply some context to that. Does that answer your whole question, or?
Yeah, that answers my question and my belief as well.
So yeah, wide events is something that, so wide events actually comes from a concept from Stripe, which comes, anybody heard of the term canonical log? So canonical log was the idea that every interaction with a service should have one log line. That's it. So if you call your order service, it should have one log line. That's it. And it should just be really wide. Canonical logs was what they came up with. Because when you're working at Stripe scale, like, these things are important. The efficiency that they got off the back of that was really important. So they came up with this canonical log concept. Then wide events was the term that we use more generically, because you don't want one log line, because sometimes you want to measure individual durations. So it's not one log line. It's just make your events as wide as possible and add all the attributes that make sense. Any other questions? One at the back. We're better. We're better. How does that sound? So when we talk to people about evaluating observability platforms, you've got to go in and look at what your outcomes are. When I talked about modern observability before, I said modern observability is about outcomes. It's not about can you ingest logging data. It's not about can you ingest tracing data. It's not about can you trace my .NET application versus my PHP application. Those are table stakes now. All of them can do it, and that's what OpenTelemetry has provided now. There's a level playing field when it comes to generating telemetry data out of your application. What you've got to decide is what exactly are you trying to get as an outcome out of that platform? Because every platform has a niche. You know, Datadog has breadth and single payer. So one big single invoice around all of your things makes things easier for procurement, and procurement is always a nightmare. So anything that gets us out of going to procurement for different tools is definitely a good thing. So that's Datadog Go with the big tent approach, similar to what Grafana's trying to do with this big tent approach. Grafana built around visualizations. You know, that's their whole thing, is building dashboards. If what you want is a load of dashboards, Grafana might be the right tool for you. If you're wanting to say, I want to do host monitoring, Datadog's the best gig in town for host monitoring. They all have their little niche. Honeycomb's niche is specifically about high cardinality and high dimensionality data. It's about getting to the real why something happened, and we do that better than anybody. So it depends on what you're looking at. If what you have is just infrastructure and you just want to monitor infrastructure, I will tell you to go somewhere else than Honeycomb, because that isn't our bag. We use metrics data from infrastructure as corroborating sources. We have a saying, nines don't matter if users aren't happy. Nobody cares about your 5 nines uptime if the users are getting 20-second response times, because 20-second response time is still up. It's like, I responded eventually, I am still here. Nobody cares about your 5 nines uptime. What they care about is the users, and that's our philosophy. We start from the user context. That's why we go with wide events. That's why we prefer tracing data over logging data, because it allows you to monitor user stuff. Rather than looking at, well, my servers were running at 90% CPU. It's like, wow, good for you. That's great. 90% is what you should be running at. If you can go for 99, that's great, especially if you're on the cloud. You heard the term, if you're renting a server, use it like a rental car, like grind the gears, because you're giving it back at the end of the day. There's no reason for you to run it at 50%. Run it at 99% CPU. Send it back to them with the CPU burnt out. Like, I got my money's worth. If that's what you care about, those CPUs and stuff like that, then there are other tools out there. So when you're looking at observability platforms, decide what you want first, and then go to the vendors and say, this is what I'm looking for. Don't go and say, can you ingest logs, traces, and metrics, because every single one of them will say yes. Don't say, can you trace .NET applications, because they'll say yes. Go to them and say, can you answer this question about my system? Now, RL have been really, I've been really annoying with them this week, because every single thing that they come to is like, well, what question do you want to ask? Literally, the answer to everything they ask me is like, but what question do you want to ask? Start with the questions. Formulate this as a question. I would like to know when users are experiencing X, Y, and Z. Great, that's a really good question. Let's work out how we answer that in that platform. And they'll all answer it in slightly different ways. Some of them charge by the user, some of them charge by the data volume, some of them charge by the metrics data points. They all do different charging models. Some of them charge for AI investigations. Some of them don't. Really depends on what you're looking for. But we're all different. Obviously, we're the best, but we're all different. Any other questions? Okay, well, I am going to be here. I'm not going anywhere. So if there's a question that you didn't want to ask in public, that's fine. Come and grab me and we can chat about it not in public. I don't know whether any of those are going to be on camera, those questions, but maybe you didn't want to do that. But thank you so much for having me. I've loved being in Skopje. It's been really, really hot, but hopefully next time I come it won't be.